In November 2025, panic swept through communities living in the shadow of Mount Rainier. Alarming online reports claimed the massive volcano was waking up, sparking fear across the region. The story spread rapidly, fueled by sensational headlines and unchecked social media posts. But the truth was buried beneath layers of digital confusion and misinformation. Our investigation starts not on the mountain, but in the digital world where the rumor began. We set out to separate fact from fiction, speaking with the geologists and seismologists who monitor Rainier's every tremor. This is the story of how a single rumor threatened public trust and how science set the record straight. Join us as we uncover what really happened on Mount Rainier and what it means for all of us. To truly understand the fear that Mount Rainier inspires in the Pacific Northwest, you must first understand the mountain itself, its immense presence, its power, and its history. This is not just a beautiful peak on the horizon. It is a living, breathing force of nature that has shaped the land and the people who live in its shadow. You must understand the mountain. Its slopes are steep and rugged, carved by ancient glaciers and battered by storms. For centuries, it has been a place of awe and adventure, drawing climbers, hikers, and dreamers from around the world. But beneath its serene, snow-capped summit lies a restless heart. Mount Rainier towers over the Pacific Northwest, an active stratovolcano capped with more ice than any other peak in the lower 48. Its glaciers are vast, feeding rivers that wind through forests and valleys, providing water and life to the region. But this ice also hides a dangerous secret. When mixed with volcanic heat, it can unleash catastrophic floods and mud flows. Its glaciers feed rivers, and its slopes are a playground, but its history is one of violent eruptions and devastating mud flows, lahars that have shaped the land and threatened millions. These lahars have carved deep scars into the landscape, transforming valleys and leaving behind a legacy of destruction that is still visible today. The last major eruption was just 1,000 years ago, and the Osceola mudflow buried vast areas now home to cities. Imagine entire communities, forests, and rivers swept away in a matter of hours. Today, neighborhoods, schools, and businesses sit atop ancient mud, a silent reminder of the mountain's power. Rainier is on the Decade Volcano list for a reason. Its proximity to Seattle and Tacoma makes it a constant concern. More than 2 million people live within range of its potential hazards, and the mountain's looming presence is never far from their minds. Scientists monitor it not because eruption is imminent, but because the stakes are so high. They track every tremor, every shift in the earth, every subtle change in temperature or gas. Their vigilance is a testament to the mountain's unpredictable nature. Any sign of unrest is taken seriously, and the public's anxiety is always close to the surface. Emergency plans are rehearsed, warning systems tested, and communities educated about what to do if the mountain awakens. When rumors fly, they tap into a deep well of regional fear and fascination. Mount Rainier is more than a mountain. It is a reminder of nature's power, a source of beauty and danger, and a symbol of resilience for those who call this region home. The seeds of November's panic were sown months earlier, during a summer that seemed, at first glance, like any other in the shadow of Mount Rainier. But beneath the mountain's serene, cloud-wrapped slopes, something was stirring, something only the most sensitive instruments could detect. In July 2025, Rainier experienced a swarm of small earthquakes, the most since 2009. The ground trembled with hundreds of tiny shakes, each one too subtle for people to feel, but together they formed a pattern that caught the attention of scientists across the region. Hundreds of tiny quakes, invisible to most, were picked up by sensitive instruments. These machines, scattered across the mountain's flanks and valleys, recorded every tremor, no matter how faint. The data streamed in day and night, painting a picture of a restless giant. Scientists quickly determined these were routine, caused by shifting fluids deep within the volcano, not magma on the move. They knew that such swarms were a normal part of Rainier's life, a sign of its dynamic, ever-changing nature. At the same time, new sensors were being installed to improve lahar detection. These advanced devices would help provide earlier warnings in case of dangerous mud flows, making the region safer for everyone living in Rainier's shadow. The upgrades in the earthquake swarm made headlines, raising public awareness and anxiety. News outlets ran stories about the increased activity, and social media buzzed with speculation and concern. For scientists, it was business as usual. They monitored, analyzed, and reassured the public that Rainier was not about to erupt. Their calm professionalism stood in contrast to the growing unease outside the lab. For the public, it was a reminder of the mountain's power. Conversations at parks and coffee shops turned to what-if scenarios, and families looked up at Rainier with a new sense of respect and worry. This heightened sensitivity set the stage for November's false alarm. Community meetings about preparedness became more common, and people paid closer attention to every update from scientists and officials. When the rumor hit, people were already on edge, primed to believe the worst. The memory of the summer's shakes and the constant news coverage made it easy for fear to spread quickly. The real events of summer became the backdrop for a digital drama. Online speculation and misinformation mixed with genuine concern, amplifying the sense of crisis. The mountain's routine rumblings had unwittingly prepared the region for panic, turning a season of scientific vigilance into the prologue for a community on edge. The panic began with a single sensational article. It was the kind of headline that grabs your attention and refuses to let go, bold, urgent, and impossible to ignore. Within hours, the story was everywhere, sparking fear and confusion in communities near and far. The Daily Mail claimed Mount Rainier was erupting, citing a graph from one seismic station, STAR, showing non-stop activity. The article described the data as clear evidence of an imminent disaster, using technical jargon to make the threat sound even more real. The story exploded online, shared thousands of times before anyone checked the facts. Social media platforms amplified the alarm as people reposted the news with urgent warnings to friends and family. The rumor spread faster than any official statement could keep up. The STAR station, an old analog site, had a history of technical glitches. Its equipment was known among scientists for producing odd readings, especially during storms or power surges, but this context was missing from the viral story. The viral graph was actually electronic noise, not volcanic tremor. What looked like dangerous seismic activity was just a technical hiccup, random static misinterpreted as a warning sign. But the article didn't consult experts or cross-check with other stations. No volcanologists were interviewed, and no one verified the data with the broader monitoring network. Fear spread fast, with anxious residents flooding authorities with calls. Emergency hotlines were overwhelmed, and local officials scrambled to respond to the growing panic. The gap between the viral rumor and the official response fueled speculation and distrust. People questioned whether authorities were hiding the truth, and conspiracy theories began to circulate. In reality, a real volcanic event would have triggered alarms across the entire network, not just one station. Dozens of sensors constantly monitor Mount Rainier, and all would have shown signs if an eruption were truly underway. The story was built on a single, faulty data point, ignoring all evidence to the contrary. It's a powerful reminder of how quickly misinformation can spread, and why it's so important to check the facts before hitting share. Scientists at the Pacific Northwest Seismic Network quickly recognized the problem. The STAR station's signal was classic radio interference, not ground shaking. A severe storm had coated the station's antenna in ice, disrupting its radio transmission. The seismograph recorded static, not seismic activity. Nearby digital stations like RCS showed no unusual activity, just the mountain's normal background noise. This cross-checking is standard in seismology. No single instrument tells the whole story. By comparing data, scientists confirmed the alarm was false. The real activity was just a technical glitch, not a geological threat. Once the error was clear, scientists moved fast to set the record straight. The PNSN and USGS issued statements. Rainier was quiet, and there was no threat. Experts criticized the media for failing to consult scientists and for misinterpreting raw data. They explained the technical glitch in simple terms, using side-by-side graphs to show the truth. This transparency helped rebuild public trust and turned panic into a teachable moment. The rapid, unified response from scientific agencies showed the strength of their partnership. Their clear, consistent messaging drowned out the initial wave of misinformation. In the end, science and reason prevailed. The false alarm had real consequences. Fear and anxiety swept through communities, causing stress and confusion. Local agencies were overwhelmed by calls, forced to debunk rumors instead of preparing for real emergencies. Repeated false alarms can erode trust in both the media and scientific institutions. If people stop believing warnings, they may ignore real threats, a dangerous outcome. Misinformation can also hurt local economies, scaring away tourists and investors. The incident is a stark reminder. Accuracy in reporting is not just ethical, it's essential for public safety. The cost of a single bad story can ripple far beyond the internet. The Mount Rainier incident highlights a crucial lesson: trust official sources. For volcanoes, that means the USGS and the Pacific Northwest Seismic Network. These agencies are staffed by experts, their data is rigorously checked, and their alerts are standardized. Their websites and social media are the best places for real-time updates. The public must also learn to question dramatic headlines and viral posts. Before sharing, ask who is the source. Is it a scientific agency or a tabloid? Journalists, too, must prioritize accuracy and consult experts before publishing. By amplifying official voices, we can build a more informed and resilient public. Mount Rainier never woke up. The real eruption was one of misinformation. The incident is a cautionary tale for our digital age. Rumors can spread faster than any seismic wave. Scientists with calm and evidence restored order and trust. Their work is our first line of defense, and supporting them is an investment in public safety. We must foster a culture of preparedness, grounded in science and critical thinking. Treat unverified reports with skepticism and champion the role of experts. Let this false alarm inspire us to seek truth, support responsible journalism, and respect the power of nature and information. In uncertain times, facts are our most valuable resource.